Okay, guys, so we're about to do day 12. I got my stuff all ready. After this, I'll probably look into that coding typing test because that's actually kind of cool that they have that. Maybe it has like all the auto completing stuff. So who knows? Like I said. So we got 20 seconds. So let me get that ready. And 10, 15, 14, 13, 12, 11. All right. So hopefully it's something that I don't cry about. I'm not going to cry about it, but you know what I mean. 3, 2, 1, go. Okay. Okay. It's cave. Okay, so it wants us to tell how many caves there are. So the first thing we need to do is we need to parse it. So so is there multiple ways? Yeah, so what? How do Why would you want to do this way? Anyways, so let pen equal that input split for each. So paths. Oh, I don't know what's something. Okay. So then path. And so what we can do is we can say if now looking at it, I don't think that'd be the best. Wait, what? Okay, so the thing is, like, you have to visit the small caves once. So you have to visit all the caves, but you can visit the capitalized caves more than once, and the lowercase only once. So neat. So if paths of I need to split it. Split based off that, and then if tokens of 0 does not exist, so if not, we shall create it, and it shall be an array. It's equal to an array, and then push tokens of 1. So now, if we display what paths are, it should be, here we go. So we have this is displaying what is connected to it, which is good. Oh, it also has to go the other way. Well, okay, so start can go to DK, and then DK can go to law. Let me do it the other way too. So that's for the first one. So if the second one doesn't exist, do that, and then bada bing, bada boom. Okay, so start can go to CI, DK, or TF, and then we want to go to end. And X and M are only connected by law, which is neat. So actually, let me go off the example, because I know, at this point, I know I'm not going to get anywhere close to the top 10, so I'm just trying to see. So start connects to A and B, A connects to start, B, end, and C, D only connects to B and C only connects to A. So like it's connected all right, but how do I find all the paths? So, I mean, we have to go from start and A, and so with that we also have to so the thing is we don't have to choose, we don't have to visit all of them. We just have to get all the paths that go from start to end and that don't visit the small caves more than once. So I mean, like I said, you could do the shortest, which is just like down here, start A to N or start B to N. But we need to have all of them, which is going to be difficult. So, what we could do is we can, we have the start. We can do A, and then we can go here, and we can see all of the paths that it can take. And so, start is we only need to do that once, so we can treat that as a small cave. So here's what I'm thinking. The problem is I don't have a piece of paper, so I can't or I don't have a way to show you what I'm writing down, but I can just explain it out loud. So we start with start, obviously, and then we go through and we visit like all the elements in the array. So we visit A and we visit B, and we keep in mind that A and B, so A is a large cave, B is a small cave. And so once we visit B, we no longer need to visit that anymore. So we keep note that we don't need to visit B. And so if we go to B, we can also, like I said, we can treat the start as a small cave, so we don't need to visit B. And so we can visit A, D, and end. And so obviously end will end it. And then if we go to A, it will go to A. And so we've already visited start. End we're not going to treat as a small cave. And then we go to C and B. But we've already visited B, so we don't need to visit again. So we need to go to C. And then C will say, okay, we got to visit A. But good news, A is already here. And so this one is like D is never listed because B is trapping it, because if you can't go back and forth. So D is never listed. So D is just an unreachable path. We will never add that. And so how do we do this with an algorithm? I mean, obviously we can do well, I should connect. I'm just going to call these connections and not paths, because paths is a variable I want to use for the total number of paths. So then down here we can define paths as an array, and the good news is the answer for part 1 is just paths.length. And so let's do, we're going to have to do a bit of recursion here, I can already tell. So let find path is equal to, well, I mean, the only thing that we need to keep track of is caves. So we need, and then so let path is equal to that, and then we need to return that path. And so what we can do is we can go to actually call this, we need to go through connections of start. So we don't need that, we just do connections of start dot for each element. So then element, we just do paths dot push, or well, we don't do paths dot push. The problem with this is that how do we find all paths? Because we have the recursion. The recursion will find, this needs to be defined before this variable. Then, nope, I deleted something I didn't want to. There we go. So in fact, if we're going to do that, then we need to push it in there. And so find path for elements. So this will find the path for A and B, and then this is where the real work happens. So cave, or I should say, visited caves. So what we need to do is find elements. So or we can just do find paths, and we don't even need to do this because like we don't even need to visit the caves, nada. And so the first thing we need to do is we need to figure out what we so if we haven't visited any caves, that means we're at start. So if visited caves length is equal to 0, we're at start. That's not right. We're at start. So we need to find the paths of with visited caves as start. That's just like probably that's the hard-coded case. So that just gets us out of the way. Or actually, we should say find paths if visited caves is equal to null, then we need to put start in there. So that just gets that out of the way. And so after we find start, now we're at AB. So else. How do we do this? So we need a current cave as well. So let current cave is equal to, or current path, I should say, current path is equal to that. If that's equal, so we can do, and then current path dot push start and string. So what this will do is this will have the current path and so now that we're here, what we can do is we can say let current options equals connections of the last current path. So current path of current path dot length -1. So this will give us what it is, and so for the first case it'll be A and B. And so with that we can go through the current options. So let I equals 0, I is less than current options dot length I plus plus. And so if visited caves, actually we don't even need visited caves at this point because we have current path. And so well, we need find paths, but we don't need anything in there. So because we already have current path, so then if the current option is lowercase a function? Let me find that. Is lowercase JS. There's two lowercase, but like, how do I do that? Okay, yeah, so two lower in the case, and so if current options of I is equal to current options of I dot two lowercase, so that means it is lowercase, and then it's already included, so and current path dot includes, actually we need to do or current options of I is equal to start and then we also need, so we're here, and current path dot contains, or not contains, includes, because that's the vocabulary that JavaScript uses.
He
So
said he didn't get an email.
So with all that, that means it's an invalid path. So for now, let's just deal with else. So else, if it does find something, then we need to find paths of, we need to find the paths again, current path, is dot push that current options. And so now what should happen is that well, now I should probably also say let current cave is equal to this, so we can get that. I didn't mean to do that. I meant to do this. And then current caves. So now, if we say if current cave is equal to end, then we push the current path into paths, and then we reset it. Is equal to not. So what this should do is this should explore each path it can take. So let me just see what happens. Visited caves not defined. Where did I put visited caves? Oh. We could just do this. So we don't need any of this if else code. And in fact, we need to initialize it with start here. There we go. Oh, maximum call set. Okay, that's not good. Let me just see where it gets stuck at. So, oh, we probably should also do else there. I don't think that's the issue, but I will put that there. And console.log current path. Okay, well, so, okay, well, it gets the first one easily. Well, the first of this, so start B, A to C to A to end. So it gets this one, but then it keeps doing that, so we need to find a way of not, I thought this would do that, but it apparently doesn't. So, let me see. Well, the problem is I want to see what my the thing looks like, but I can't do that because I have to console.log connections. So there we go. So it does it right. Well, I don't know why it doesn't start with A. It's kind of weird. I mean, unless it does. So then it goes to A to B and B to A and A to C and C to A and then A, and we've already visited C and B, so end, which is the only option. We've already visited start C and B, so end is the only option there. So that, like, it works for that path. I'm trying to see though how we can stop it from keep taking the same path over and over again. So then I thought that this would do that. I don't think I'm doing recursion because I'm just doing this over and over again. So I actually think I need to make this recursive. So I think I do need to do path here. So find paths with start as the initial. So current path is out, so that means that means I don't need you, I just need path. So we get the most recent one, so this should be start. If it's equal to that, path stop. So push this path. Else, so if it's not included or state, maybe I need to do something to that with right now. I don't need to, so current path, and then find paths. I know what I can do. I can do path. Let new path equal this. So path, and then include that next option. So current options of I, and then plug that into the recursive. So that should do something. Current is path not defined. Where's current path? Oh, path here. Shouldn't have any more current paths. I'm sorry, did that work? What? Hold on a minute. There's no way. Did that just work? No way. Oh my gosh. What? Okay, so a single small cave. What's a single small cave? Oh, okay, only once. Okay, so this is a bit more complicated. First one, I'm not gonna lie, I just wasn't expecting to get that like that. That was a complete shocker to me. So anyways, now we're at part 2. So now we can only visit one cave, one of the small caves, once. So I'm gonna go back to this input because, yikes. Just see. Okay, yep, same code. So now, we're only allowed to visit one of the small caves once. Which allows D to be in the case. So let's do it. Okay, so for that to happen, we need to be able to detect how many caves we can do that in. So seeing it now, so this is the case where, like I said, that it was probably used for part 2. Let me see what we got here. So this is basically saying if it's a lowercase cave or it's the start one, then you can't. And like if it's a lowercase cave we already visited, or it's a start, don't use that. But now we need to add a condition in here. So else, let's count how many we have. So now, let's go through the current cave. Current path, and then it's the same here, so path I is equal to path of I dot 2 lowercase. So let current small cave visits. And then now we need to do if not current small cave visits of path of I, then we increment it, or we set it equal to 0, and then we increment it. So what this will allow us to do is this will count how many times we visited a small cave. And so I'm just going to console.log current small cave visits. So this allows us to oh wait, we gotta get rid of and then path of I is not equal to small cave, or is not equal to start. I mean, not small cave. So this will just allow us to get here. So now, see, right now it's all 1, which is correct. We only wanted it to be 1 in the first part, but now we want one of them to be 2. Exactly 2 or more than 2? Exactly 2. So to do that, now when we are assessing which options we can go to, so current option, if it's lowercase, and we don't need this, we don't need this one because it's about to get a lot more complex. So I'm going to put that on a line by itself. So I'm going to just true here, just so I can have some formatting. So there we go. So now, and then if current small cave visits of that current option is I is equal to 1, and then there's no other, let 2 cave visits is equal to object dot values object dot values of current small cave visits dot filter element is equal to element is equal to 2. So, and that is dot length is greater than 0. So if and not 2k visits, yeah. Okay, that's not exactly what I want. So if it's a small cave and, oh wait, we have to do not of this. Well, the not is, well, no, I'm just gonna do a simple bah. Okay, well that removed all of them, which is not good. So let's see. So if current small cave visits, so let me actually print that. So current small cave visits and 2 cave visits. Oh. Well. The thing is, I only really want to do that when, so basically, only take that path if there isn't a 2k visit. Well, actually, I don't see the need for this then. I don't see the need for that. Okay, well, that still hasn't changed anything. So, Wait, okay, so if it's false... Let's see what happens if I do it like that. Okay, so... Well, that opens it up, but there's still only 10. In fact, let me just see what those 10 are. If there should be 36, so paths. Oh, they're the same. Yeah, they're the same. So, which I'm confused of because it has this, which is an option. It's right there. Oh, I see because it stops as soon. The thing is, it stops as soon as there's 2 cave visits, which isn't correct. So if it's a small cave and there's been 2 cave visits, but the thing is, so with that is that, you know, for this case, the second cave visit is B, and B has an end. So I'm not for sure, because here B would be twice, and then it would go to A, which would go to C, which would go to A. So if it's so what did I do for part 1? I did, and it's not already included. But the thing is, we can include it just one time. So, and that's what these current small cave visits. So, if it's...
there were people using that space in particular.
Let me do... Oh, wait, no, I don't want that. I want that parenthesis.
It's empty now, but I don't...
So, if...
I worry about them getting a little bit, if they come back and
if it's a small, so if it's a small,
what do you think about that?
A small letter, or if it's a
and
small
also, what about
cave,
the second floor space? Is that one taken?
If it's a small cave and start,
all right, well,
so
I guess
that's our initial.
Come claim this one.
That's our initial one. So then we also need to determine. This just for organization purpose. Like I said, I could just put this
I'm
in
gonna
the same line,
and then I'll get back
and
to
then.
Alright,
yeah. So if it's a small cave, current small. Else if it's okay, well that's good. So if it's a large cave, which is basically what this is doing, then continue finding the path, or finding all the paths. But if it's a lowercase, or it's start, so this will also run if it's start. So if and then if it's start, we could put that in else if current options of is it current options or current cave? Yeah, current options of I is equal to start. And then we just don't do anything. And then else. So if we're at a small cave, then we need to determine if we have 2 cave visits and we've already reached our maximum. So what we need to see is if this requires a second cave visit, or if first thing we need to do is if we can do a second cave visit, then we shall allow it. but then else if we can't. So let me say if not 2 cave visits, then we allow this. Then we allow a new path to be found. Or we allow a new cave to be found with that. So that else, if we do that, then we just need to allow normal stuff to happen. So, which is basically here. So if 2 cave visits already happen, we can determine if it's the if it is. So then if 2 cave visits already happened, then what we could do is we can say, are those cave visits for the current one? So basically, what this will do is this will say, okay, is that the one? Is the one that we have the second? And we just need to say, we're not going to wait, that doesn't make sense, because then yeah, because it would be at this case, so then this one will activate the 2 cave visits, and so then we'll go here, and then the next time it'll say it's lowercase, and then it'll activate it, and then oh, I see what it's trying to we only disallow it if we visit the next cave, will it add 2 2s? So 2 cave visits total, and so, and then if 2 cave visits total is greater than 1, then we get out of it. We don't push the path, basically. And so that should just allow us to do that. Oh, 2 cave visits. Where else did I put? Okay, here. So if it's, oh, well, then it will stop. The problem is this will only allow basically, actually, we just need it to stop if it's not start. Is not equal to start. So that was pretty simple to do. Then we allow it to find a new path. Okay, we'll see. It's just getting hammered. That's not right. I don't know why C is just repeatedly. Oh, I know why. And currents. And current.small k visits of the current option is not equal to 2. Oh, hey, look. Hey, oh my god. It just works, which I'm not used to. It just happens, which is kind of crazy to me. Okay, so if we put our actual input, it starts to, oh, not exactly die, but yeah. Oh my gosh! I did it! I wasn't expecting that. Okay, well, first of all, how long did it take someone? So it took someone 5 minutes to do it. There's probably a much better way of doing it than the way I did it. That caused me to took 40 minutes. So let me show my leaderboard, personal sets, just for the recording. So I got 1719 and 1951. So not that great, but I mean, I wasn't at this point, like, I'm not actually going for leaderboard because unless we get a super easy puzzle later on, I'm not going to get it. Anyways, I mean, yeah, that's it. Bye, recording.